Hello guys, welcome to the mathematics lesson on matrices. Okay, so today we are going to go ahead with the matrices lesson 2. Yeah, so remember in our previous lesson I gave you a task on matrices, lesson number 1, and I didn't have time to type those solutions so that I can revise them with you today, but I promise I'm going to type them and probably send a video tomorrow on how you should have answered those questions. Okay, but in today's lesson we are going to continue with the operation on matrices. Okay, so we are continuing with operation on matrices. In our previous lesson, we looked at 3 operations that are performed on matrices. We looked at addition, subtraction, and the multiplication. Okay, so in today's lesson, we are going to look at the identity matrix, which is represented by I. Okay, so we have what we call identity matrix, and it is represented by letter I, like this. So an identity matrix can be like this matrix here and this matrix here. So by definition, an identity matrix is a square matrix whose elements in the major diagonal are ones and the rest are zeros. Yeah, so an identity matrix is a square matrix whose elements in the major diagonal are ones and the rest are zeros. So it is just a square matrix whose elements in the major diagonals are 1 and the rest are zeros. So like this, we have this is a diagonal we call major, and this one is another diagonal we call minor. So we have in this major diagonal ones, and in the rest we have zeros. Also here we have, like, this is the major diagonal, we have ones, and the rest of other elements which are not in the major diagonal are zeros. So such a matrix, this is an identity matrix and this one is an identity matrix. All right, so also you must understand that this is what we are calling major diagonal, and this one is what we are calling minor diagonal. Okay, so also you must understand also that such a matrix like this one, okay, so such a matrix, you also must understand that such a matrix like this one, it is a 2 by 2 identity matrix. So this one is a 2 by 2 identity matrix because it has 2 rows, 1, 2, and 2 columns, 1, 2. But this one, it is a 3 by 3 identity matrix because it has 3 columns, 1, 2, 3, and 3 rows, 1, 2, 3. Okay, so what you must understand is that an identity matrix produces a matrix it is multiplied with. What am I saying? These are the concepts, guys, that you must be taking care of when a sentence is spoken or a statement is given or a theory. That theory is what you take as a concept, because this is a concept we are giving you to say an identity matrix produces a matrix it is multiplied with. So when you get this matrix, you multiply this identity matrix, you multiply it with a different matrix, a normal matrix. Then the final answer should be that normal matrix. It is as though you never multiplied that matrix with anything, or it is as though you multiplied that matrix with 1. So this is what we mean here. If you have matrix A, which is equal to these values here, 2, 2, 3, 1, then they say find, if they say AI, which means matrix A times an identity matrix, because I stands for identity matrix. So here we mean that if you have AI, it means matrix A times identity matrix, it will give us this matrix you place, because where there is A, you put this matrix, then where there is this, we pick this one here, we put it. we could have picked this, but you cannot multiply these two matrices like this and this because they are not in the same order. The number of columns in this one is not equal to the number of rows in this, so you cannot multiply. These are not multiplicable, or rather cannot just be multiplied. So that's why I picked an example with this one, because these two can be multiplied. Now the thing here is this: when you multiply like this matrix with an identity, the final answer will be this matrix. And I'm urging you to take note of this. So let me just push this one. So this is this and this. We are multiplying a normal matrix with an identity. So the multiplication, remember in the previous lesson we said you must multiply. When multiplying these matrices and this, you get the row and the column, and then the row and this column. Again, this row and this column. Again, this row and this column. Okay. So we are starting like we get 2. So 2 times this 1 here. Then after you do that, 2 is done. Then you shift to this other 2. As you shift to this other 2, you say plus. So you say this 2 times 0. So 2 times 0. Okay? Then after you have done that, you have picked this times this plus this times this. Now this is done. Now you shift to this. As you shift to this, you don't put a plus. So you just get 2 times 0. So you put separately 2 times 0. Then you have done it 2 times 0. Now as you pick 2 times 1, you put a plus. Then you say 2 times 1. Okay, this is very important because multiplication is one of the things that makes matrices hard, because it confuses pupils most of the time. Okay, so times 1. Then after you have done that, you have completed this times this times that, then you shift to 3 times again 1. So 3 times 1. Then as you come to 1, you say plus, then 1 times 0. So 1 times 0. Okay, you are done. Then you want also to come to this, so you say 3 times 0. So don't put plus, you just say 3 times 0. Then as you come to this other one here, 1, so you say plus 1 times 1. Okay, then just put these back. Then you say equals. Then you see that here, now what you are going to have is like, we go step by step. So 2 times 1, 2. Then you get your plus, you put here. Then 2 times 0, 0. Then you get this one, 2 times 0 here. Okay, you have shifted to this. 2 times 0, it is 0. Then plus, you put here. Then 2 times 1, 2. Then you come here. 3 times 1, 3. Then plus here. Then 1 times 0, 0. Then you come here. 3 times 0, 0. Then you put plus here. Then 1 times 1, 1. You see? Then after that, you complete now here. You say, okay, so AI, which is matrix A times identity, it will give us you get this plus this 0. So this will be actually the final answer, meaning 2 plus 0, 2, 0 plus 2, 2, 3 time plus 0, 3, 1 plus 0 plus 1, 1. So you have seen that we have come up with the same matrix. This is the same matrix we had, and this is the final answer. This now vindicates the statement, or verify or confirms the statement we had given, that if you multiply an identity matrix with a matrix, the product is just that matrix you multiply it with. So these concepts are very important, because examiners can twist questions in a way that if you don't know these concepts, even if you have done the concept or the topic on matrices, you may miss to answer a question that may come from it. So then we are saying this now is equal to matrix A. Okay, so this is matrix A. Then we are saying A times A, it just produces matrix A. That's what we have seen. So if you get a matrix, then multiply it with an identity, then the answer is just that matrix. This is what we are putting in a statement like this. Okay. Then another important operation on matrix is what we call determinant of a matrix. Very, very important that you understand what a determinant of a matrix is. A determinant. So we are saying, what is a determinant? So guys, we are saying it is the difference of the product of the major diagonal and the product of the minor diagonal. So if you have the product of the major diagonal, you subtract the product of the minor diagonal, the result you get is what we call determinant. So an example is here. Example, we have matrix A, which is these values. Then if the question says find the determinant of A, this is how you do it. Solution. And we always abbreviate this determinant of A like this. We just write det A, which reads determinant of A. So determinant of A is found as shown equals. So you get these are major diagonal. You multiply them like 2 times 1. Then you say minus. Then minor diagonal. Okay, this 3 times 2, 3 times 2. Okay, then after that, what you are going to do now is equals. So 2 times 1, 2, minus 3 times 2, 6. Then you say, okay, determinant now is equal to 2 minus 6. You get negative 4. Okay, very, very important to know this concept. So this is how we find the determinant, guys. Okay. Now, we can use the determinant of a matrix to find an unknown element of the same matrix. So we can use the determinant of a matrix to find an unknown element of the same matrix. So you may be given a matrix whose elements are missing. And if you know at least the determinant of that matrix, it is very easy for you to know the missing element or the unknown element. Okay, like here, an example is here where we are saying A is matrix this, K, 2, 3, 1. So K is an unknown element. If they say find element K, if determinant of matrix A is negative 4. So if the determinant of this matrix A is negative 4, then they're asking us to find element K. Remember here we said we can use this determinant to find an unknown element of this matrix. So in answering this, we'll say solution. We will say determinant of matrix A. First of all, we'll start as if we are finding the determinant of matrix A. That's how we find. We'll say, oh, that's how we'll start. So we are saying determinant of matrix A is equal to major diagonal minus minor diagonal, which means K times 1, which is K, okay, minus then 3 times 2, which is 6. Okay, so after we do that, then we are going to realize to say determinant A is already provided. The determinant of matrix A is negative 4 here. So meaning we are going to pick where there's this, we will put 4 because this part is just equal to 4. So we'll replace with negative 4, then we'll say equals, then it is going to be K minus 6. Then this one becomes an equation, okay? It becomes an algebraic equation because it has 2 constants and then it has a variable. And in evaluating algebraic expression, we always collect like terms, okay? Like this is a constant and this is a constant. So these are like terms. So you collect them on one side. So in this case, we decided to move this constant the other side of the equal sign. So like we'll have negative 4. When negative 6 crosses this one becomes positive 6 equals, then here we are going to have K. Okay, so meaning we are going to add negative 4 plus 6, we are going to get the positive 2 equals K. Meaning Therefore, this k is equal to 2, meaning the unknown element which we needed to know that k was 2. Okay, so this is how we use the concept on a determinant to find the unknown element. Okay, then next we go to inverse of a matrix as another operation carried out on matrices. So inverse of a matrix is another operation that is carried out on matrices. So here, guys, you must understand that an inverse matrix, it is a matrix which when multiplied with another matrix produces an identity matrix. So here the explanation is that if you get an inverse matrix, you multiply it with a normal matrix, the result you get is an identity matrix. That matrix which has the major diagonal 1s, the rest of the elements 0s. So that's what you get when you get an inverse matrix. You multiply it with what? With any other matrix. So let's say we have an inverse matrix. You are multiplying it with a normal matrix A. So it's as good as saying normal matrix A times an inverse matrix. Now, the product you get is an identity matrix. That's what it means. So if you have an inverse matrix times a normal matrix, you get an identity matrix. Very, very important to know this knowledge, or rather these concepts, because they work in what I said, transformation. Like identity matrices are used commonly in transformation, as we are going to see. So here we are saying in general, if A is equal to this matrix here, A, B, C, D, then we are saying the inverse of matrix A is found as shown. So if they say this is A is this matrix, then they say find the inverse of this matrix A. We are saying the inverse of this matrix A is found as shown. Like the inverse of this can be written as this. Inverse of this matrix is equal to, then you get 1 over det A, determinant of A. You get 1 over determinant of A, okay? Then you multiply it with this. Now, check what has happened here. We have swapped. A comes here, then D goes where A was. That's what we have done here, okay? We have swapped, okay? So here, in fact, I made an error in typing. So let me correct this error very quickly. Okay, so I've corrected. So this one, D, which was here, comes here, then A comes where there's D. Then what happens to this? You introduce negatives. You introduce negatives. So when you get this, you multiply by this, you get what we call an inverse of this. Now, this is what we call a formula. This is just a formula that we can follow whenever we are finding the inverse of a matrix. So let's go into the details, or let's give you an example of this situation here. Okay, so this here is an example. We are saying if A is equal to this matrix here, then the question says find the inverse of matrix A. So the solution will be like this. So inverse of matrix A is equal to, so we'll get 1 over the determinant of this matrix first, which is 4 times 2 minus 1 times 3. So 4 times 2, 8, minus 1 times 3, which is 3. So 8 minus 3, it is going to produce 5. So this becomes the inverse because determinant of A is 5, which we have seen to be 4 times 2, 8, minus 1 times 3, which is 3. So 8 minus 3, 5. So 1 over 5, then you put times this. Now here we have swapped. 4 has come here, 2 has gone here. So you see 4 is here, 2 is here. Then we have put negative where there was no negative here. We have introduced negatives. Then after you do that, then you start multiplying. This becomes just a scalar number which we are multiplying with each element inside the matrix. So you multiply like, okay, so here you multiply this value with each element inside the brackets or of this matrix. So you go like equals, so you like 5 times 2. 1 over 5 times 2, you get 2 over 5. Then 1 over 5 times negative 3, you get negative 3 over 5. Okay? Then 1 over 5 times negative 1, you get negative 1 over 5. Then 1 over 5 times 4, you get 4 over 5. So this is the result that you get. You have seen, right? So this becomes the inverse of this matrix. So the inverse, find the inverse of matrix A, it's this answer here, guys. Okay? Nothing more, nothing less. Okay? Then the other operation on matrices you need to know is what we call transpose of a matrix. Very important concept, transpose of a matrix. So what is a transpose of a matrix? We are saying to transpose a matrix means to interchange the rows as columns. So if you have been given a matrix, then you start interchanging the rows become columns. Then you have just transposed a matrix. So we are saying if A is equal to this matrix here, then the transpose of matrix A is expressed as AT. So you'll find in an exam they write AT, meaning they're saying transpose of matrix A, because they can just say find AT. In that, they've said find the transpose of matrix A. So you need to get again familiar with the language that examiners use. So the transpose of matrix A is expressed as A power T, okay, can be found as shown. So if they say AT, meaning transpose of matrix A is equal to, so now the rows becomes the column and then column becomes the rows. So like this first column or row become the first column, okay? So it will be like this. So the first row becomes the first column and then the second row becomes the second column rather. So that is the concept you go with. Whenever you are transposing, the first row becomes the first column and then the second row becomes the second column. Okay, so simple. This is a very simple concept, right? So we have transposed, we have changed the rows, have become the column. The first row, the first row has become the first column, the second row has become the second column. Now let's move and look at the next operation, which is the adjoint of a 2 by 2 matrix. So again, this is another operation carried out on matrices. So we are saying an adjoint matrix is a matrix obtained by interchanging the elements in the major diagonal and changing the signs of elements in the minor diagonal. Okay, so when you have a matrix, then you interchange the elements in the major diagonal, and then you change the signs of the elements in the minor diagonal. Then what you come up with is an adjoint matrix. So an example is this. If B is a matrix which is this one here, if they say find the adjoint of matrix B, so if they say find the adjoint of matrix B, then you follow this concept, because adjoint again is said add B. So this is also read as adjoint B. So again, this is the language of mathematics. So adjoint B is equal to, so what you do, you interchange elements here. So you are going to interchange. This one should go here, this one comes here. Okay, so you find 2, then you write 4. Then next, what we do, you change the signs here. Here the sign is negative, Here the sign is positive. So here the sign again becomes, here you put positive, here you put negative. That's how you do. So because of this concept where we said an adjoint matrix is a matrix obtained by interchanging the elements in the major diagonal and changing the signs of elements in the minor diagonal. So we are changing the sign. This was negative becomes positive. This is positive becomes negative. Okay, so this is negative becomes positive 3. This is positive 1 becomes negative 1. So this one becomes the adjoint. Okay, so with these concepts, guys, that you are being equipped with, you are going to be very, very versatile at handling questions or problem to deal with the matrices. So to end the lesson, here is a task. Okay, you have this task number 1. A is this matrix and B is this matrix. If they are saying if A times B is equal to B times A, find the values of A and B. Meaning if you multiply like this matrix times this matrix, you multiply them, then you find that they're equal. So meaning you are just going to substitute this, you put here, then this one you put here, again here you put this matrix, again here you put then you do the multiplication. As you do the multiplication, you find a situation where you are going now to find the values of A and B very well. Okay, so try to do this, and I'm going to show the answers in the next lesson that we are going to have. Then they're saying if the determinant of a matrix, this one here is 12, find the value of A, like the one we did there, the value of A. Again here they're saying if a matrix, this one here, does not have the inverse, find the value of X. If it doesn't have the inverse, then find the value of X. What do they mean if it doesn't have the inverse? Okay, so if it doesn't have the inverse, then it means that its inverse is 0. All right, then they say now find the value of X. All right, so in the next lesson we are going to see what the answers are going to be. So guys, as for now, bye. See you in the next lesson in our group.